I'm Shweta, assistant professor from the Department of Geography, Fakir Mohn University, Balaswar. I all welcome you all. Today, we have arranged a lecture series program. So now India is celebrating the 100 years of glorious 100 years of geography education across the country. And in this occasion, our department, which is the Department of Geography, Fakir Mohn University, which has organized a series of special lecture. And in this occasion, our first lecture will be delivered by our esteemed speaker, Dr. Atul Saini sir. So, the main purpose of our arranging the lecture series program, the purpose of this series is to bring the distinguished speaker across the country, both locally, nationally, internationally, who were working in the diverse field of geography. So we want them to bring to this platform to share their research experience, share their knowledge with the young mind. So today in this light, we have with our distinguished speaker, Dr. Atul Saini from Hemavati Nandan Bahuguna Gharwal University of Uttarakhand. So I welcome you, sir. Welcome to the department. Before proceeding to the session, would like to give a brief introduction about Dr. Saini. Dr. Atul Saini, which is a young dynamic geographer who is currently working as assistant professor in the Department of Geography from Hemavati Nandan Bahuguna Gharwal University. So he is recognized as for his intensive research work in the field of climate variability, climate modeling, monsoon dynamics, climate and agriculture, and so on. So he is, though his research, teaching experience is a short period of time, but still in such a short period of time, he have published a number of research articles, both nationally and internationally recognized. So he have more than 25 articles in his pocket. So we today we would like to hear you, sir, about a burning topic, that is climate change and its relationship with shifting of monsoon pattern, which is, I'm sure, which is very much helpful for the young minds, for the student, which is I will wish all the participants to listen to our distinguished speaker, and over to you, sir. Thank you, sir.
Thank you, madam. Thank you for the nice introduction in the starting of this session. So it is nice to meet you online, and maybe in the near future we will meet somewhere in Fakir Mohn University or some other platform. So thank you, madam. So today, let me share my screen. So I think my screen is visible to all of you. Is it visible?
Yes.
Yes, sir.
Okay. Thank you for the confirmation. So in the starting, I would like to thank the head of the department, postgraduate department of geography, for inviting me for this interesting session on understanding climate change and shifting monsoon pattern. So today we will see how the climate change is now more real within a short period of time, because climate change is something which keeps going on the Earth's surface. or in the atmosphere. So in the recent past, what has changed? Why climate change has become so popular? So we will go through this, and after that we will see why the climate change is now a problem for a complex phenomena like monsoon in India. So before going deeper into different concepts and discussion, we will see what is climate change, climate variability, and what is weather. So here from this figure, you can see that climate change, climate variability, and weather are different from each other as far as the time scale is concerned. You can see here, climate change belongs to the change in climate which spans for more than a decade, or when we talk the change in centuries. But climate variability is for a shorter duration of time in comparison to climate change. It is for months, years, or for decades. But when we talk about the weather, it could be change in the atmospheric condition which belongs to hours, days, right? So there is a difference between weather, climate variability, and climate change. Here on the left side of this slide, you can see El Nino, La Nina, flood, drought, positive and negative Indian Ocean dipoles. All these phenomena are part of climate variability because these changes in a short duration of time, like these changes in months, years, and decades. So these are part of the climate variability. So we will discuss about these more in detail in the next slides. But this slide is only to introduce the concept of climate change, climate variability, and weather. So globally, as far as the definition of the climate change is concerned, so World Meteorological Organization also considers that climate change belongs to the change in the climatic condition which spans for more than 25 or 30 years, right? So climate variability means the changes at a monthly, yearly, or decadal scale. So similarly, the shorter duration is weather. So moving next, yes, so why the climate change has become a climate crisis in the recent past? What has changed in the atmospheric condition? So climate crisis is something which refers to the severe and escalating impacts of human-induced climate change. So one very important point which you should note here is that climate crisis is because of human-induced climate change in the environment, society, and global system. And it is something which is really very urgent, and it is of very high magnitude. And due to this high magnitude of change in the climate, everything in the atmosphere is now becoming like irreversible. We cannot bring the normal state of climate in a very short period of time because the changes are happening so fast and that everything is becoming irreversible. And by the end of 21st century, the situation will be more harsh. So let's go through the journey, how the climate was in the past. So going through the journey of the climate, we will see how the climate has changed and how it has brought some new things over the Earth's surface, like organisms and various other things. So here from this slide, you can see there are different geological times here in this slide. So from the bottom to the top, you can see the journey on the horizontal axis. Here on the top, you can see time are classified into different categories. Eon is the largest category in which we divide the time when we talk about the geological time scale. So eon, era, and epoch. So within an eon, there are different era, and in an era, there are different periods, and within different periods, we have different epochs. So at the bottom, you can see in the Hidden era, formation of the earth took place, and after that, moving towards the top, we can see different changes took place, and on the left side of this figure you can also see different time period in which mass extinction took place. Here the first mass extinction took place in Ordovician time period, Devonian time period is the second one, Permian, Triassic, and the most recent mass extinction took place in the Cretaceous time period. And this was the extinction of dinosaurs. So why this extinction and all these changes took place? What were the factors responsible for it, and what was happening at that time? So we will go through all these things. There is some issue in changing the slide, so it is taking a little time. So yes, so we have seen in the geological time scale how the things were changing, and the origin of Earth took place in the first stage, that was Hadean Aeon, and in different time scales, different episodes happen. So when we are going to discuss the monsoon, particularly in the Indian context, we should be aware that in which particular period, in which particular geological time, how the monsoon, particularly in India, was performing. So in the Cretaceous period, Indian subcontinent started its northward journey, right? So it was part of the supercontinent Gondwana, and I hope most of you are aware of the plate tectonics, because most of you, I hope, are geographers. So in the Cretaceous period, when the northward journey of the Indian subcontinent started, it collided with the Eurasian plate, and the collision of with the Eurasian plate vanished the Tethys Sea in between. So there was a Tethys Sea in between. So with the collision of the Indian plate with the Eurasian plate, Indian plate was a part of the Gondwana, right? So in the Cretaceous period, this collision took place, and in the Eocene epoch, the formation of the Himalaya, which was the most important episode as far as the origin of monsoon in India is concerned. So with that collision in Cretaceous period, formation of Himalaya took place in the Eocene epoch, and formation of Himalaya was the most important episode. Why? Because the Himalaya, we know, is the tallest mountain range on the Earth's surface, and this plays a very important role in the origin of the monsoon. Why? Because this is a barrier which is a restriction for the cold northern winds, right? And this high altitude mountain range also help the wind to move upward, and then the condensation takes place and rainfall happens. So this Himalayan range plays a very important role, and the formation of this Himalayan range took place in Eocene epoch. Then next is the Pleistocene epoch, and in this monsoon system, particularly Indian monsoon system we are talking about, monsoon system become more mature and robust. Robust means it became more stable, and in the Pleistocene epoch, rainfall in the whole South Asian region started happening with the increased rate, right? So this rainfall, monsoon rainfall, supported the development of different ecosystem, and this was the main foundation for the human civilization in the Indian subcontinent. We all know about the Indus Valley civilization and various other civilization on the Indian subcontinent, and at present we know that India has more than 160 crore population. So this is dependent on the monsoon system, because even today majority of the Indian population is dependent on agricultural activities for their survival as a part of livelihood, right? So this was something which happened in the past, and this was responsible for the origin of Indian monsoon. So Indian monsoon is not so I think my screen is visible to all of you, because there was an issue. I think it got freeze. Is it visible?
Yes, sir, it's visible.
Okay, thank you. Okay, now let's see how these geological changes happened, right? So whenever we talk about the geological timescale, we do start the journey from the origin of the Earth, because everything started happening around this blue planet only after its origin. So with the origin of the Earth, there was abundance of methane, ammonia, water vapor, and carbon dioxide. And we know that methane, ammonia, water vapor, and carbon dioxide, all these are the greenhouse gases. But with the origin of the Earth, the sun was little fainter. It was not so harsh comparatively as we see it in the present time. So comparatively, it was a little fainter. But with the abundance of all these greenhouse gases, the temperature was very high. But gradually, when the Earth started cooling down, with the Precambrian era, life started emerging on the Earth. And in the Precambrian era, when the life started emerging, it was in the form of very simple form, like it was unicellular, right? Because whatever we see around us in the present time, we see organisms are multicellular, the abundance of multicellular organism. But at the initial stage in the Precambrian era, when the life started emerging, it was unicellular. So the unicellular life in the oceans helped the increase in oxygen level on the Earth, because most of the unicellular organisms and some algae or bacteria were surviving based on the photosynthesis mechanism. So that photosynthesis mechanism started increasing the level of oxygen in the atmosphere, right? So with the Precambrian era, life emerged and oxygen levels started increasing. Now the rise of oxygen was a turning point. Why? Because the presence of oxygen, which was already at an increased level, so that increased level of oxygen was responsible for the formation of ozone layer. And we know that ozone layer is the layer which protects us from the harmful UV radiation, ultraviolet radiation. So after the Precambrian era, ozone layer became more mature and robust, right? Why? Because the oxygen level increased. So after that, in the climate across the globe went through different phases. So the next one is the phase in which everything was frozen. So during the cryogenian period, Earth experienced the extreme glaciation events. And in that extreme glaciation event, Earth was like a snowball. Why? Because everything was frozen. So extensive glaciation was there, and there is still a speculation that that glaciation was so intense that even near the equator, there were thick ice sheets. So after the warming phase, this is the phase in cryogenian period that everything was frozen. So it reduced the temperature and impacted the life, because earlier, whatever life form which was in the simpler form, that was unicellular, started getting impact of this snowball earth. Now next comes is Cambrian explosion, in which life started diversifying. Diversification of the life happened, marine life proliferated a lot and new species came into existence. So in the Cryogenian period, there was a remarkable burst of life, right? So you can see how the things are changing with the change in temperature and the situation in the environment, right? So greenhouse gases and the ice house world came into existence later on when the life diversified. Why? Because amount of carbon also started increasing a little. So there were different drivers of climate change on the earth, right? So plate tectonic was the one very important driver. Solar output is another one, orbital variation, volcanic activity, and biological activity. All these are very important natural drivers. There is no role of human being. All these drivers are the natural drivers. And you can also see in the second column that when we talk about the plate tectonics, the time scale is in millions of years. And because this is a very slow process, plate tectonic process is a very slow process and it takes millions of years and it affects the ocean currents, mountain building, and the CO2 cycling. Similarly, solar output is a driver which changes in billions of years, right? So time scale of different natural drivers is different, which are responsible for the change of climate on Earth's surface. So all these are the natural drivers which were responsible for the change in climate in the geological time scale, right? So what we have learned from the Earth's climate history, that the climate on the Earth's surface is very sensitive. Any change, even if it is not a catalytic change, our climate is sensitive to each one of them, right? So our climate is very interconnected. A change at a distant place brings changes to some other place. For example, a change in the Pacific Ocean brings change in the Indian region. So our whole climate across the globe is interconnected. And life has its own adaptability. We have seen that from the warming phase, when we entered from the warming phase to the snowball phase in the Cryogenian period, life started extincting. Why? Because organisms, those who were surviving in the warmer phase, were not used to the climatic condition which was available there in the Cryogenian period. So life has its own adaptability, and changes in the climate brings the long-term consequences. So now let's see the Holocene period and its journey till we reach the Anthropocene period. So in the Holocene epoch, a stable climate was available, and it is about 11,700 years ago when the stable climate was available, and stable climate was responsible for the agricultural revolution. Because if we are experiencing very fast change in the climate, it is not possible for human society to adopt the sedentary lifestyle, because we know that in the next 50 years or 100 years the climate is going to change. So in the Holocene epoch, a stable climate was available and agricultural revolution took place. With that stable climate, population growth was very rapid in the Holocene epoch. Why? Because of the stable climate. So after the Holocene epoch, there was the dawn of Anthropocene, and in Anthropocene, here comes the role of human being. Human dominance took place in the Anthropocene. and climate crisis came into existence. Right? Why? Because with the dawn of the Anthropocene, we entered into the Industrial Revolution phase when we were able to produce lot of products in a very short period of time using machines. And machines were based on the fossil fuels, right, like coal, petroleum, diesel, various other fossil fuels, and wood was available. So in the mid 18th century, industrial revolution began, and it marked the shift towards mechanized production. Technological advancement took place. Rapid innovation led to the increased production and energy consumption worldwide. So with this industrial revolution, we here in this picture also, on the left side of this slide, you can assume a situation in which industrial revolution is taking place and a lot of carbon emission is also happening at the same time. So here you can see lot of smog we have emitted into the atmosphere, and along with this smog there were lot of greenhouse gases, like we have already discussed: methane, carbon dioxide, carbon monoxide, right? Water vapor is also one very important greenhouse gas. So we have emitted a lot of greenhouse gases in the atmosphere with the industrial revolution, and this changed the atmospheric composition of earth, because we know that in our atmosphere carbon dioxide, methane, nitrous oxide, and various other greenhouse gases were present at a constant rate. There was no rapid change in the amount of all these greenhouse gases, but with the industrial revolution, a huge change took place in the concentration of all these greenhouse gases. So what is greenhouse gas? What is greenhouse effect? We are discussing about the greenhouse gases. Greenhouse effect is something in which solar radiation stucks in a particular envelope, kind of, you can say, in a envelope, in a bubble. Our atmosphere is like a bubble covering earth. So whenever the solar radiation enters in our atmosphere in a particular bubble kind of thing, which I am calling atmosphere, it becomes very difficult for that solar radiation to exit from that atmosphere. Why? Because there is abundance of greenhouse gases present in the atmosphere, and greenhouse gases have the property to absorb the solar radiation for a longer period of time, right? So increased greenhouse gases were responsible. Greenhouse effect, heat trapping started happening, and it led to the concept of global warming. Temperature started increasing because when the retention power of our atmosphere is higher for the solar radiation, temperature of the atmosphere will keep on increasing continuously, and it will make the environment warmer, and this results in the global warming. So why the global warming is now again a very important issue? Because we as a human are now practicing deforestation, because after the Holocene, right, as we have discussed here, after the Holocene we entered into the Anthropocene, and in the Anthropocene, when the human population started increasing with a rapid rate, requirement of the human population also increased. So to fulfill the requirement of the human population, we needed vacant land to practice agriculture. We needed vacant land to make different residential colonies. So we started doing deforestation. We started removing the forest, right? And we all know that forests are a good carbon sink, carbon sequestration agent. Why? Because forests are dependent on carbon dioxide, because this is one very important component of the photosynthesis process. Forest needs carbon dioxide, soil, solar insolation, and water. So carbon dioxide, whatever is inhaled by the forest, is stored into the stem of the tree for a longer period of time, or till the tree die. So it stores the carbon dioxide into its stem and leaves. So for a particular duration of time, it stores carbon. And this helps in reducing the extra amount of carbon dioxide in the atmosphere. So if we are cutting the trees, we are removing the carbon sink or carbon sequestration agent, which are helping us to decrease the impact of global warming or climate change, right? There are different industrial processes are also responsible for the carbon emission. We have already discussed that manufacturing and different chemical production is taking place in different manufacturing hub. Waste management is poor, and therefore a huge waste from the industries are now getting piled up in the form of landfills. So these all the industrial processes are also responsible for the climate change. So now let's see how much global warming we have experienced in the recent past. So when we see the time period from 1880 to 1980, global average temperature has increased by 0.08 degrees Celsius per decade, and it has increased by the rate of 0.18 degrees Celsius per decade during 1981 to 2020. But when we see the recent past, when we see the future from 2021 to the end of the 21st century, the average global temperature increase is projected to be 0.3 to 0.7 degrees Celsius per decade. So you can compare the rate of increase. It was lesser earlier during 1880 to 1980, but the projected increase rate of increase in the temperature is higher, 0.3 to 0.7 degree Celsius per decade. So this is because of the greenhouse gas emission in the atmosphere. So in the late 18th century, what was the state of temperature? Whatever temperature was there in the late 19th century, it was with the natural rate of change, right? So whatever temperature was there in late 19th century, it was with the natural rate of change. But with the onset of the Industrial Revolution in 20th century, global increase in temperature was observed, and in the last 4 decades, there is a rapid acceleration of warming, and the data says that 1.1 degree Celsius increase has taken place in the last 4 decades, and in the last 7 years, record-breaking temperature has been experienced at different places across the globe. And various scientists and researchers fraternities say that this is the warmest period in recorded history. So you can see what has happened with the Industrial Revolution. So ice sheets and glaciers are melting, right? Polar ice sheets at the North Pole and at the South Pole also, and in the Himalayan mountain range and in some other high elevation mountain range like Andes, Alps, glaciers are melting and retreating continuously. I am here in Uttarakhand, and I know that Gangotri Glacier and various other glaciers have retreated a lot and are continuously retreating. So this is the present state because of the high amount of greenhouse gases. So the amount of water in the sea is also increasing, and this is responsible for the sea level rise, right? So at present, about 20 centimeter rise has been experienced since the 19th century, and we consider 19th century as the baseline standard. Why? Because before that, the instruments were not available, the observation of the data from different locations was not possible. So we consider late 19th century as the normal state, and whatever change we are experiencing at present, we compare it in context of 19th century. So at present, 20 centimeter rise in the sea level has been experienced since 19th century. Ocean warming and acidification of the sea is taking place, and this is again a danger for the coral reef, right? So the capacity of our oceans to absorb heat is now exceeding, and oceans are now absorbing over 90% of the excess heat. And with this, I would like to mention that recent study by a scientist in India, IITM, Indian Institute of Tropical Meteorology, has shown that Arabian Sea is warming with the rapid rate. Why? Because we have increased the amount of carbon dioxide in the oceans also. How? Because we have seen that whatever carbon dioxide emission we have done in the atmosphere, it is now getting dissolved in the rainfall water, in the water which we receive through rainfall, and that water ultimately goes towards the ocean through rivers. So that excess carbon dioxide is now going towards the ocean, and that carbon dioxide is now absorbing the excess heat in the oceans. And when the oceans are warming, warmed oceans are responsible for the extreme events like cyclone, like cloud burst, flood, drought. So these kind of events are now becoming more visible. So as I have already mentioned, extreme weather events are now a new reality and looks like the new normal. Hurricanes and typhoons, heat waves, flood and droughts are now more visible. Biodiversity loss is taking place. Why? Because each and every organism on the Earth's surface have a particular threshold limit of temperature and precipitation, and if the conditions will go beyond those threshold limits, there will be huge danger on the survival of those organisms. And therefore, habitat loss, species migration, phenological changes is new reality, and in the exceptional case, the extinction of different important species of flora and fauna is also taking place. So with this, we should also know that there is a feedback loop. If you change a particular element of the atmosphere or on the surface of the earth, it will result in a new change, and that new change will again bring a new change. So one initial change will feed the second change will feed the third change. So like this, there will be a loop. The first change is intensifying, the second is intensifying the third, and ultimately we are experiencing intensified climate change. So here you can see if there is Arctic sea ice loss, then it will reduce ice cover, and reduced ice cover will lead to more heat absorption, and more heat absorption will result in accelerated warming. And ultimately, this accelerated warming will again result in the Arctic sea ice loss. So this is the first loop. So similarly, here we have some other examples also. you can see the ocean circulation. If the ocean circulation changes, it results in the global heat distribution. Why? Because we know that we have some cold current and warm currents. So if there is ocean circulation change, it will change the global heat distribution, and the change in global heat distribution will result in the regional climate shift. So we need to ultimately stop the emission of greenhouse gases so that the initial change, like Arctic sea ice loss or ocean circulation changes, can be stopped before it originates. So, whatever we have discussed so far, we have seen that in the geological time scale, a lot of changes has happened, and how we have reached at a present state in which we are experiencing climate crisis. And facts are very visible to all of us, that what we have done in the last 20 years, 40 years, and we have also seen in the last 7 years, temperature has increased a lot, and scientific fraternity is saying that we are at a record high. So we all know that there is a heat budget of Earth, and when we are disturbing that natural heat budget, we are disturbing something which was balanced. And if the heat budget is now getting disturbed, that imbalance is now again a problem for the nature. So nature is trying to balance itself, and we are creating a lot of greenhouse gas emission, and this greenhouse gas emission is again a challenge for the nature to rebalance itself. So nature is continuously trying to rebalance itself because we have disturbed the heat budget, and heat is the only element which we can call is the energy which is driving the winds, which is driving everything which we can see in our environment. Even if it is carbon cycle, nitrogen cycle, winds, cyclones, everything is dependent on heat. And if we are trying to disrupt the heat budget of the earth, which is a natural phenomena, then there will be huge loss of natural state of climate. So the devastating changes of the climate we can see through different studies which we have completed in the recent past. So here is the first one, evaluation of the observed and future climate change projection. So in this study which got published in the Atmosphere Journal, we tried to see that how the climate has changed in Uttarakhand and what is its future. So future of Uttarakhand is really very harsh. Why? Because in different climatic scenario, whenever we project the future climatic condition, we do see the changes in different scenarios. Different scenarios means what will happen if there will be the emission at a medium rate, what will happen if the emission will be at a very extreme level. So on the basis of different emission scenarios, we make different scenario for the climate model also. So future climate scenario on the basis of RCP 4.5, we can say that Uttarakhand is projected to experience a 5.92% decrease in annual average precipitation by mid-century. And in a little harsh scenario, in RCP 8.5 scenario, the precipitation is projected to increase by 2.83%. right? So in different scenarios we try to look that what will happen in future. So this is about the climate models, because what model means miniature of the reality, how the future will look like if something like this happens. So in different scenarios we can see in case of Uttarakhand that climate will be little more harsh if we do not control the greenhouse gas emission. So these are the different temperature projections for different time periods for Uttarakhand: mid century projection, end of the century projection. So by the end of the 21st century, RCP 8.5, which is a harsh or extreme scenario, it projects that there will be 5.49 degrees Celsius increase of the maximum temperature. So accordingly, we need to adopt the adaptation strategies. So these are some other results. So change in climate is also responsible for the impact on human health because of increased heat stress, respiratory issues, and mental health of the human being is also under the huge impact due to the changes in climate. Because in the case of heat wave, or in the case of high moisture in the environment, we know that human nature becomes little more anxious, or human being becomes little more frustrated. Why? Because the amount of moisture in the atmosphere is higher and the temperature is also higher because of the heat wave. So there is huge impact on the human health also. So vector-borne disease like malaria, dengue are also on the rise because of the change in the temperature, precipitation. And interestingly, we have seen in this study which got published in the scientific report, this study shows that there will be increase in the malaria transmission in Odisha, right? So the results shows that the temperature will rise by 3.5 to 4 degrees Celsius by the end of the century in Odisha. There will also be increase in the rainfall. Rainfall will increase by 20 to 30% by 2080. So with this, there will be decrease in mosquito density in most of the districts, but with the decrease in the mosquito density in most of the districts, there will also be the increased incidences of mosquito bites. So several districts with higher elevation in Odisha and dense forest regions like Kandhamahal, Koraput, Raigad, Mayurbhanj are projected to experience an increase in malaria transmission by the end of 21st century. So you see, whatever we are discussing, whether it is vector-borne disease, right, whether it is future projection of the temperature, we are discussing about the change in temperature and rainfall. Why? Because these two important parameters plays a very important role in the change of climate. Because if there is change in the temperature, it will change the moisture content in the atmosphere. If there is change in the precipitation, there again will be the change in the moisture content or the type of precipitation we see over the Earth's surface. So temperature and precipitation are two very important elements when we are discussing about the climate change. Similarly, here is again another study, climate change projections and its impact on potential malaria transmission dynamics in Uttarakhand. So again, using the same model, that is the vectory model, which we used for the case of Odisha, when we were trying to study the malaria transmission, we used the same model for Uttarakhand also to see how the malaria transmission will take place by the end of 21st century in this mountainous state. Because In the case of Odisha, the situation was a little different because majority of the part is not of that high elevation. So in the case of Odisha, we have seen that there will be increase of about 30% in the mosquito bites, and it indicates an increase in future malaria transmission in case of Uttarakhand, right? So as far as the food security is concerned, because we know in India we are now more than 160 crore, and to feed each and everyone we need food grains and we need good crop production. So with the change in climate and with the change in the behavior of the monsoon, there is again an impact on the food security for country like India. Extreme weather events like flood, drought, cloudbursts are responsible for the change in the crop yield annually. Nutrition content of the food is changing. Why? Because of the different CO2 levels, which affects the photosynthesis process of the plants. Food prices are changing a lot. Why? Because everything in India is dependent on the performance of the monsoon. If the monsoon is good and is successful, the food crop production spikes and the food prices decreases. So if the change in climate is taking place, it will impact the food security also. So here in this study which got published in Sustainability Journal, we have seen that some distant location like the Central Pacific is changing the crop production of rice in Bihar. In Bihar, majority of the population is dependent on the agricultural activities, and the staple crop of Bihar is rice because majority of the people do use it as their food, and majority of the farmers produce it. So if there is change in the conditions of Central Pacific Ocean, then it will directly impact the rice production in Bihar. So you can see that how the distant location, that is Central Pacific, is responsible for the change in the rice production in Bihar. The distance is in thousands, but still both the places are connected to each other. So here through this map, as I have already mentioned, that Central Pacific is responsible. So here you can see this is Australia, right? So this is South Asia. This one is South America, North America. So when the Central Pacific region, you can see this is in red color. So the temperature of Central Pacific region is responsible for the change in the rice production. And why this Central Pacific region is responsible for the change in the rice production in Bihar? Because trade winds, which becomes the southwest monsoon for India, travels through this region. And if the sea surface temperature of the sea surface, when it becomes warmer than normal, it disturbs the trade winds, and the disturbance in trade winds disturbs the rice production in Bihar, because majority of the agricultural land in Bihar is still dependent on the monsoon rainfall. And if the monsoon fails, the rice production will fail, and if the monsoon is a success, then the rice production will boom. So this red color is a case of El Nino. You must have studied El Nino and La Nina. So El Nino is a case which is visible here in Central Pacific. So El Nino is a case in which sea surface temperature remains higher than the normal continuously for more than 3 months. So it becomes the case of El Nino and the Central Pacific becomes warmer than normal. So here red color is showing that Central Pacific is warmer than normal and impacting the rice production in Bihar. So climate change is again responsible for the displacement of human being and for the flora and fauna. So here in another very important study, we have seen that apple orchards are now shifting towards the higher altitude in the Himalaya. This is not a natural shift, but yes, farmers, those who were growing the apples earlier, are now growing something else. Why? Because at that particular elevation, optimum conditions for the apple is not prevailing there. Climatic condition has changed with the passage of time, and we know that apple in the Himalayan region are generally grown at an altitude of 1500 or 2000 meter, but with the change in climate, that belt of temperature has shifted towards the higher elevation, and now in some of the regions where cultivation of apple was not possible due to very low temperature, people are growing apple. Why? Because the temperature has increased and there is no more snow on the earth's surface there. So at present it is possible for them to grow apple, and now the poor farmer of the higher elevation have become millionaire with the climate change. So there is again advantage for some farmers and disadvantage for some farmers of climate change. So the study got published in the PLOS One journal, in which we have shown that why the apple orchards are now shifting towards the higher elevation in Himachal Pradesh. So in 1980s, when the apple orchards were located at the elevation of 1200 to 1500 meters above the sea level, these apple orchards have now shifted at an elevation of 3500 meters. So this is something which looks like a magic, because earlier at 3500 meters, nobody can imagine to have apple orchards, but now with the increase in temperature, it is now possible to grow apple at 3500 meters, but at 1200 to 1500 meters elevation, it is not possible. Why? Because the apple growth needs some chilling hours. Chilling hour means hours in which the temperature is below 7 degrees Celsius. So apple cultivation needs at least 1500 chilling hours in a year, and if there is decrease in the chilling hours, then there will be no good growth of the apple. So I have already mentioned about the chilling hours, and so at the higher elevation of Himalaya, now farmers are expecting some new opportunities, as we have seen in the case of the apple orchards. So farmers are expecting some new opportunities for some new crops which were not present there earlier. So what are the challenges for the low altitude region as far as the apple orchards are concerned? With the passage of time, low altitudes are now experiencing heat stress. There is scarcity of water, and with the increase in temperature and precipitation at the lower altitude, pest and disease pressure is there. So whatever apple growth is taking place at a lower altitude, it is prone to different pest and disease, and therefore farmers are leaving the practice of having apple orchards at the lower altitude. So this is the result of climate change in the recent past. So climate change have its impact on the economy of also agriculture, fishery, tourism, everything is under the impact of climate change. Crop failure incidences we have already discussed. So climate change also changes the marine ecosystem. Why? Because it increases the temperature of the sea surface. Tourism also get under the harsh impact of the climate change due to the extreme weather and habitat loss. Infrastructure got damaged due to the climate change. In case of Odisha, we have already set an example how to cope up from the impact of the cyclone. But yes, we can save the human life from the cyclone in Odisha, but there will be infrastructural damage due to the cyclone. So increased intensity and frequency of the cyclone anywhere across the globe is the result of climate change. There are a lot of global security concerns because we have seen in the case of Siachen Glacier in India, which is a point where defense forces of 3 different countries keep on maintaining their post to claim their jurisdiction. So with the change in climate at the higher elevation like Siachen Glacier, there will be availability of the new land because the glaciers will go away with the change in climate, and the availability of the new land over there will be again a point of conflict for different countries. So migration is taking place from one region to the other region. Why? Because the climate change is again bringing a lot of extreme events like flood. So we have recently seen in the case of Saudi Arabia also that the flood is taking place in the desert of Saudi Arabia. So that flood in the case of Saudi Arabia in future will be responsible for the migration. So political instability will be there if there will be again high intensity of the climate change. Why? Because climate will induce economic stress on different countries. So we need to take different mitigation efforts, adaptation strategies, and global cooperation is very much necessary. And when we talk about the global cooperation, it means that all the countries or representative of different countries need to sit at the same platform to discuss a common solution for the whole globe. And yes, we have done very good in the past also. Global community have taken a lot of initiatives to control the rate of climate change. So here we can see that initiatives taken at the global level are like UN Sustainable Development Goals, and the time frame for UN Sustainable Development Goal is from 2015 to 2030. We have 17 interconnected goals when we talk about the UN Sustainable Development Goals, and we need to achieve all of them. And it will definitely help us to control the climate change. We at the global level have Green Climate Fund, and it is still going on. We have a very important institution by the name of IPCC. IPCC is an institution at the international level which keep on releasing its reports for the future climate. So the recent report was the assessment report number 6, which got released in 2021-2022. And post 2022, global biodiversity framework also came into existence, and time frame for this initiative is 2020 to 2030. So like this, we have different ongoing initiatives at the global level, and we still need to make the consensus to control the climate change. Because we have seen in the past that countries like US and some other countries have shown the black flag for the global initiatives for the climate change control, but it should not happen, and we should not debate on the developed and developing countries, what developed countries have done and what developing countries are doing. We need to make the consensus to control the climate change. So here again, the same slide which we have discussed initially in this session, and this slide is again here. Why? Because we are now going to discuss about the El Nino, La Nina, flood, drought, positive and negative Indian Ocean dipole, and their role in changing the performance of monsoon in India. So how these different phenomena are playing their important role to change the monsoon in India. Monsoon is a very big word, and monsoon is something which is responsible for the survival of 160 crore population in India. Otherwise, we have some huge rivers like Ganga, Brahmaputra, Indus. All these rivers receive their water supply from the glaciers, and all these glaciers receive the water from the monsoonal rainfall or the moisture, whatever we have in the air, which comes through the monsoonal wind. So if there is disturbance in the monsoon performance, there will be disturbance in the life of 160 crore people. So what we have seen as far as the climate change is concerned, a lot of changes is happening in the Earth's atmosphere. And what are those changes? We have also discussed all those, and what are the consequences. So now we come to the topic monsoon. With the change in climate, how the monsoon is changing. So before going deeper into the topic, that is monsoon and climate change, let's discuss about El Nino, La Nina. What are these? El Nino, I have already mentioned, is something in which the temperature of the Central Pacific region becomes warmer than normal continuously for more than 3 months. If the temperature of the Central Pacific is warmer than normal continuously for more than 3 months, it becomes the episode of El Nino. And when the El Nino in Central Pacific region prevails, it is, I would not say is a guarantee, but yes, it is a prediction that we are going to receive less monsoon rainfall. But in case of La Nina, when the Central Pacific region becomes cooler than normal, it is a signal that we are going to receive excess rainfall in the Indian subcontinent. So El Nino and La Nina are two different cases which do exist in the Central Pacific region, and it influences the performance of the monsoon. And here at the top you can see the neutral phase in which Central Pacific region is neither warmer and nor cooler. So similarly, in the case of Indian Ocean, you can see here we have India, and on the western side we have Africa, and on the eastern side we have some Southeast Asian countries. So Indian Ocean dipole is a new concept, and this exists in the Indian Ocean, and therefore the name is Indian Ocean dipole. And why dipole? Because here two different poles develop with different temperature. When the eastern part of the Indian Ocean is warmer than normal and western part is cooler than normal, we call it negative phase of the Indian Ocean dipole.
Hello, sir.
But
Sir, your screen is not visible.
okay. Let me check.
Hello.
So is it visible now?
Yes, it is now visible.
Okay, thank you. So As we have seen in the case of El Nino and La Nina, there is again another phenomena which do exist in the Indian Ocean, and we call it Indian Ocean dipole because there are two different poles, one with the warmer temperature and another one is with the cooler temperature. So there are two different poles, and when the eastern side of the Indian Ocean is warmer than normal and western side is cooler than normal, it becomes the negative phase of the Indian Ocean dipole. And when we are talking about the temperature that is warmer than normal or cooler than normal, it is about the sea surface temperature, not the air temperature. Air temperature is the atmospheric temperature. So this is the sea surface temperature. So we have seen the negative phase, and in case of the positive phase, the opposite phenomena or the reverse cycle takes place, in which the eastern part of the Indian Ocean is cooler than normal and western part of the Indian Ocean is warmer than normal. So here I would like to highlight, for the good performance of the monsoon or for the excess rainfall of monsoon in India, positive phase is very much responsible. Why? Because when the warmer western side is existing, it boosts the southwest monsoon circulation. Why? Because it creates the lower pressure on the western side. Atmospheric pressure on the western side due to the warmer than normal sea surface temperature conditions boosts the monsoonal winds towards the Indian subcontinent. But in case of the cooler than normal, that is in case of the negative phase, the higher pressure originates on the western side and this dissipates the monsoon winds. So positive phase of the Indian Ocean dipole is a good signal for a good performance of the monsoon. So we have seen that El Nino is sometimes a guarantee for low rainfall in India. La Nina is a guarantee for excess monsoon rainfall in India. So suppose there is a situation in which there is coexistence of La Nina as well as positive phase of Indian Ocean dipole. So the cumulative impact of both of these climate modes brings a huge moisture flux towards the India. Why? Because La Nina is supplemented by the positive phase of Indian Ocean dipole. Because positive phase and La Nina both are responsible for the excess monsoon rainfall. And if both of these phenomena are existing at the same time, the cumulative impact becomes so huge that majority part of the India is in danger of having flood. So as far as the monsoon is concerned, we know that monsoon is a term which belongs to the movement of winds from one direction to the other direction, right? So there is not only one monsoon region across the globe, that is South Asia. There are 8 different regions in which we experience monsoon: North American monsoon, South American monsoon, North African, South African, Indian monsoon, Australian monsoon, East Asian monsoon, and West North Pacific monsoon. But South Asian monsoon, that is Indian monsoon, is the monsoon which is responsible for the survival of a very huge population. And Himalayan range at the north of Indian subcontinent is a very important factor for the good performance of southwest monsoon. So Indian monsoon is sometimes comes under the impact of monsoon variability, and due to the variability of monsoon, increased flooding, drought, or the origin of cyclone takes place. And what does this monsoon variability means? Monsoon variability means the amount of rainfall which monsoon is delivering in India. If the monsoon rainfall is in excess, it will result in the increased flooding. And if it is scarce, it will result in the drought. So monsoon variability occurs due to the changes in the climate modes. That is El Nino, La Nina, Indian Ocean Dipole. Right. So to study the monsoon in India, we have used different boundaries for India because we are very much familiar with the administrative setup of India in South Asian region. So here you can see the administrative boundary of India, but on the other side in panel B, you can see different boundary lines for India, and in C, again, we have different setup of the boundary lines. In D, we have again a square shaped or rectangular shaped colonies kind of boundaries for India. So different boundary lines for India have been used to study monsoon in India differently. Because this is a natural phenomenon, it doesn't know the administrative setup. So let's see long-term trend of the rainfall in monsoon season. So how the monsoon rainfall is changing and how much change has taken place. So we have studied a long duration of time, that is about a century long, from 1901 to the near 2019 or 2014. So we have seen that in that long period of time, monsoon has changed its rainfall amount. So for studying the amount of rainfall delivered by the monsoon or the trend of the monsoon, we used this kind of boundary line setup, and here you can see different sub-regions and some larger regions. So the larger regions which you can see with a particular color are the monsoon homogeneous regions, and monsoon homogeneous region means a particular region in which the rainfall amount is almost similar. So in India, we have 5 different monsoon homogeneous regions, and we have about 36 meteorological subdivisions. So meteorological subdivisions are further subcategorization of the monsoon homogeneous regions. If you can see here, the northwest monsoon homogeneous region have 6 meteorological subdivisions. Meteorological subdivision number 17, 18, 13, 14, 21 and 22. So India have more than 306 rain gauge stations, and rain gauge stations are the stations which observes the amount of rainfall at a different location. So this is the setup of the rainfall rain gauge stations. So using the data of all these rain gauge stations, we have seen the rainfall trend which is century long, that which spans from 1871 to 2014. So here are some brief methodological points which we have used to calculate. So generally what the researchers do, they do use a parametric or another non-parametric method in a single research article, but in this article which got published in a journal by Springer, so in this article we used parametric, non-parametric as well as a graphical technique which is a little new technique, that is innovation trend analysis. So we used all these 3 different methods to refine the result of rainfall pattern for India, and the results shows that meteorological subdivision number 4, 20 and 27 have the significant trend. Decreasing trend has been observed in meteorological subdivision number 4, 20 and 27. And significant trend means that we can rely on the result whatever we have in front of us using all these different methods. So there is always a level, like how much we can rely on the results. 90%, 95%, we have the confidence that our result is good. So this result on the trend of the rainfall is more than 90% significant. And we have also seen, as far as the trend of the rainfall is concerned, that there is a decrease in rainfall over Uttar Pradesh, right? And coastal meteorological subdivisions in India on the east and west have clear signals of increase in monsoon rainfall. So I have already shown you the map of different meteorological subdivisions. So do not confuse with the number of the meteorological subdivision. Each and every meteorological subdivision have their own number, and it has been explained in the legend. So when we were talking about the meteorological subdivision number 4, it was referring to Nagaland, Manipur, Mizoram and Tripura region. So meteorological subdivision number 4 is here. So results are referring to different regions, and these are very significant trends. So this significant trend of the monsoon rainfall means that the monsoon rainfall amount is changing, and it has changed in the last 1 century.
Sir, your slide is not changing the subdivisional map.
Okay.
यूट्यूब में नहीं यूट्यूब में आ रहा है नहीं आ रहा है क्या यूट्यूब में मैं देखा भाई आ रहा है अभी क्या हम लोग तो यूट्यूब चल रहा है भाई
So I think now it is changing, right?
Yes, the LRM and MKT slide.
Okay. So now let's move on to the next important point, and it is about understanding the spatio-temporal characteristic of monsoon onset in different climate modes using objective methodology. So objective methodology I have mentioned here. So objective methodology is something which is based on some statistical methods, not based on some threshold limit. Because what used to happen that IMD also since long used to consider the threshold limit for different regions to announce that monsoon has arrived. So later on, IMD has also changed its process of monsoon onset declaration, and they have now adopted the objective methodology. So monsoon onset is something which is really very important as far as the monsoon performance is concerned. Why? Because the date on which the monsoon comes in India, it decides how the stock market of India will perform. It decides when the farmers should sow the seeds in their agriculture land, and it also decides various other things which are part of our socio-cultural web of India. So we need to understand if there is some important characters of monsoon onset in different climate modes, or is it something very general. So to do this with the objective methodology, which is based on the statistical techniques, here is the boundary setup for India, and this boundary setup of India is again based on different parameters. For example, here you can see a region with code number 15. So why we have coded this region with 15? Because this particular region receives the monsoon onset when some multiple parameters which are responsible for the arrival of monsoon crosses their threshold limit. So this particular region has its own threshold limit for different parameters. Similarly, sub-region number 11 has its own threshold limit for different sub-region, for different parameters. Like this, we have divided the whole country in different sub-regions and used objective methodology. So to study the monsoon onset behavior, here you can see how complex is the monsoon, that we used rainfall, precipitable water, total cloud cover, all these parameters. Because it is not possible to understand monsoon only through one or two parameters. It is not possible that if you have a temperature, rainfall, or wind speed, then you can study monsoon, because monsoon in itself is a very complex phenomena, and scientists, even the finest scientist in India, is still having the speculation about some of the monsoon phenomena. So we have not yet understood the monsoon completely, and therefore we used different parameters to understand the monsoon arrival in India. Geopotential height at 200 hectopascal, and different layers of the atmosphere you can see here: 850 hectopascal meridional wind, lower tropospheric thickness, upper tropospheric thickness. So these all different variables belong to different regions. These does not lie only in India. You can see geopotential height at 200 hectopascal belongs to 25 degree to 35 degree north and 50 degree to 100 degree east region. And I will show you all these regions in different slide. So let me show you those regions. So here in this slide you can see different parameters are taken from different regions, and the performance of different parameters in these regions will decide when the monsoon is going to arrive in Rajasthan, when the monsoon is going to arrive in the central part of India, in northeastern part of India. So therefore you can see we used different variables. So here is the methodology. So to identify when the monsoon is going to arrive, we use the rainfall data, which is 0.25 degree resolution, NOAA NCEP data for the period of 1951 to 2017, because beyond this it was not available. And we used this data for different sub-regions. Sub-region number 1, 2, 3. We divided the whole India in 19 sub-regions. And having done this, we decided to study the arrival of monsoon onset in different climate modes. What if there is flood in India? What if there is drought in India? And how the monsoon will perform when there is the episode of La Nina or El Nino. So we have studied the arrival of monsoon onset in different modes.
Hello.
Hello.
Sir, I think PPT is not visible to the student.
Okay. I don't know what is the issue, but this is happening for the first time. Let me share the full screen.
Yes, sir.
So now I am sharing the entire screen, and I hope the issue will be resolved. So I think now it is visible to all of you.
Yes, sir.
Is it visible now?
Yes, sir.
Dave, is it visible?
Yes, sir. Visible now.
Okay, okay. All right, so now, as I was discussing about the monsoon arrival in India in different climate modes, so this is a very little complicated, but not very complex methodology. But yes, to understand the monsoon, we used this methodology, how it will perform in different climate modes. So we used local hydrometeorological index, and to calculate this, we used different 8 steps. And to calculate the general and regional atmospheric circulation intensity index, we used 5 different steps. So these are these steps we used for LHMI and Garaki index. And these 2 index are very important to determine when we are going to have monsoon in different subregions in India. So both the index LHMI and Garaki have their own threshold limit, and this is the table of that threshold limit. So whenever the threshold limit is crossed, we can announce that the monsoon has arrived, right? So here, having used the methodology which I have already mentioned, we got the result that in the case of La Nina years, here in panel A at the left top corner, you can see in the case of La Nina years, majority of the Indian subregions are experiencing earlier rainfall. This dark tone of blue color is representative of the early onset. Here at the bottom, legend is showing that if there is a dark color of blue, it means that the monsoon will arrive earlier by a week. And if the color is red, and if the red color becomes more darker, it means the monsoon will arrive late. So in panel B, you can see Rajasthan, Uttarakhand, Haryana, Punjab region is in dark red color, or we can also call it a little brown color. So it is representative of the late monsoon arrival by a week or more than a week. So in case of La Nina, you can see early onset, and in case of El Nino, there is late monsoon onset. But in case of positive Indian Ocean dipole, there is mixed performance. Some central Indian part and Jharkhand is experiencing earlier onset of monsoon, but some other region are experiencing late monsoon onset. However, in case of the negative Indian Ocean dipole, majority parts of the India is now experiencing late monsoon onset arrival. However, in case of the flood, if there is no La Nina, no El Nino, in that case also sometimes India experience flood or drought. So those neutral years also receives flood drought. So here in case of the flood, when there was no La Nina, El Nino, positive or Indian Ocean dipole, but the flood took place, so the situation was early arrival of the monsoon in majority parts of India. But in case of drought, again there is late arrival or late onset of the monsoon. So these results are 95% significant, right? So again, here in this slide, you can see the temporal expense. In panel A, you can see in case of La Nina, y-axis is showing different years in which La Nina took place, and x-axis is representing different subregions, subregion number 1, 2, 3, 4. So in majority of the La Nina years, different subregions have experienced early monsoon onset. But again, in panel B, which is representing El Nino, different subregions in different El Nino years is representing late monsoon onset, and which is sometime more than 7 days. So here, for example, in year 1972, when the El Nino took place, majority subregions of India were having late monsoon onset by a week. Again, in positive Indian Ocean dipole and negative Indian Ocean dipole, you can see the similar kind of performance which we have seen in the case of La Nina and El Nino. And again, in flood and drought, You can see in case of flood, there is early onset in majority part of the sub-region, and in case of the drought, there is late onset of the monsoon. So there is a link in between the climate mode and onset of the monsoon. If El Nino is there, is a surety that majority part will receive late arrival of monsoon. But if La Nina is there, it will give the surety that yes, arrival will be little earlier. So now let's see, is there any relationship between monsoon onset and length of monsoon season and consequent rainfall event? So please look at this statement very carefully, because this is very important part of today's session. That is there any relationship between the monsoon onset and length of monsoon? If the monsoon onset is earlier, will it guarantee that the length of monsoon season will be larger or smaller? And if yes, it is a guarantee that earlier monsoon will bring a larger monsoon season. So the larger monsoon season will bring more rainfall or less rainfall. So there is a connection between monsoon onset, length of monsoon season, and the rainfall amount which we receive. So what is the relationship between all of these? So here is a simple map showing the onset of monsoon. So in panel A and in panel B, you can see the scheme which was earlier used by India Meteorological Department to show onset and monsoon withdrawal. In panel A is for monsoon onset, when the monsoon onset will take place in different region, and in panel B, the scheme of IMD showing monsoon withdrawal, when the monsoon will withdraw. But recently, IMD has also changed the scheme or changed the method using which they used to determine the monsoon onset and withdrawal in India. And therefore, in panel C and panel D, you can see there is now a change in the lines showing the monsoon onset and monsoon withdrawal. So why there is this change? Is this change because of the change in climatic circulation? Yes, we have seen that in the last 7 years, 20 years and 40 years, temperature has changed, atmospheric circulation is changing, we are experiencing more extreme events, and therefore the behavior of the monsoon is also changing. Arabian Sea, I have already mentioned, is now warming, and the warming of Arabian Sea is again point to worry as far as the performance of the monsoon is concerned. So the institution, the most trustworthy institution in India, that is IMD, has now changed its boundary to show the monsoon onset and monsoon withdrawal. So this is just a schematic diagram to mention. So here you can see, as far as the monsoon onset is concerned, is there any trend of monsoon onset? Is monsoon onset getting late, or is it getting earlier as far as the timing is concerned in different regions of India? In peninsular region, northeast, west central, central northeast and northwest, how the monsoon onset trend is going on. So it does not show a very significant trend, and this is visible from this figure on the left hand side. But on the right side of the slide, you can see the monsoon season's length anomaly. Does the monsoon is changing its length? So you can see there also we don't have very much significant trend, but in case of the west central region, yes, we can say that monsoon is now getting little late. So this is just a linear regression trend to have a brief overview of the monsoon onset trend and monsoon season's length trend. So using this linear graph, you can have an idea for different subregions in India how the monsoon onset day and rainfall are connected to each other. On the left hand side, you can see y-axis is representing monsoon onset day, and on the x-axis,
स्क्रीन तो नहीं दिखाई दे रहा है
it is showing rainfall in millimeter. So the first column, is representing JJAS season. JJAS season means the monsoon season. So what is the relation between the onset day and rainfall amount? If the monsoon onset is earlier, will it give excess rainfall or scarce rainfall? So in case of JJS, you can see in different subregions. In case of peninsular India, northeast India. So in central northeast region and northwest region, there is a significant connection, or we can say the trend line is showing that if the monsoon is late in northwest India and in central northeast India, it will give higher monsoon rainfall. So like this, for the whole India, we have seen that there is strong connection between the monsoon onset and monsoon rainfall. If the monsoon onset is earlier, it is a prediction that excess monsoon rainfall will happen in majority part of India. And similarly, is there any connection between the monsoon season length? If the monsoon season is larger, how much rainfall will it give? Will it give a excess rainfall episode, or will it give scarce monsoon rainfall? So if the monsoon season's length is larger, it is a prediction that more than normal monsoon rainfall amount will be received by majority part of the India. Here in this figure, or in the map of different subregions, you can see that there is strong correlation between extreme excess days and rainy days. Extreme excess days means rainfall with high intensity in a very short period of time. So if rainy days are more in a particular monsoon season, then it is also a guarantee that we are going to experience more extreme excess days. And the correlation is very strong. Here you can see in peninsular sub-region that some patches are showing the positive correlation of more than 0.9, right? And in case of central northeast, northwest region and west central region also, you can see majority part is showing the positive strong correlation. Now let's look into the grid-wise spatial analysis of monsoon onset. What do we mean by grid-wise? We use grid data, and grid data is something like
Sir,
yes.
your screen is not visible, sir. Your screen is not visible, sir.
I think the issue is not at my part. Maybe the internet is slow at your end. So please check your internet.
Okay, sir. Okay, sir. We are checking our internet connection.
So is it visible now?
The screen is visible, sir.
Okay, thank you. So now let's look into the grid-wise spatial analysis of monsoon onset. So I was explaining what a grid means. So grid, as far as the data is concerned, grid is like a pixel when you see your TV screen. Sometime if you must have seen your TV screen from a very close distance, you must have seen multiple square shaped pixels in that TV screen. So these small pixels are like grid of a data. If we do cover the whole India or a whole globe with a canvas or with a sheet, we can draw different square shaped grid over that. So all those square shaped grid are part of the grid data or the raster data. And when we combine all those grids, it becomes a raster or grid data. So it is very important in today's time that we should use raster data or grid data. Why? Because it covers a very larger region at a very fine scale. Each grid have its own size. It can be 1 square kilometer, 1 kilometer by 1 kilometer, or it can be 25 kilometer by 25 kilometer. So IMD releases rainfall data for India with a resolution of 0.25 degree. So 0.25 degree means 25 kilometer by 25 kilometer approximately. One grid is having a size of 25 kilometer. So to do grid-wise analysis for India, as far as the monsoon onset is concerned, we used piecewise linear regression method. And piecewise linear regression method is something which can easily identify the break in the data. When is the break is taking place in the time series data, and why is that break? So piecewise linear regression method identifies that break easily. So here in this figure, you can easily see there is a point near 4 and 5 on the x-axis, and it is labeled as C. So this is a break. So suppose before this break, there was no monsoon onset, there was normal rainfall or the weather was very clear, but when the monsoon onset took place, you can see the spike in the amount of rainfall. So this sudden spike in the rainfall can easily be identified by the piecewise linear regression method. So we used piecewise linear regression method, and the data set was rainfall data released by IMD that was with 0.25 degree resolution. We did pented analysis. Pented analysis means we combined 5 different years and made the composite image of those 5 different years. So in the panel A, you can see 1901 to 1905, how the situation looks like. In panel D, you can see 1916 to 1920. If we do composite 5 different years, is there any signal of the monsoon onset? And is there any connection of those 5 different years with El Nino, La Nina, drought, flood? So pented analysis could not give a very clear picture, and therefore we decided to look into each year from 1901 to 2019. So here is annual spatial analysis. So here you can see if there is El Nino, then you can easily identify that due to El Nino, majority part of the India is in red, and El Nino, La Nina year are on the right. So like this, annual spatial analysis has been done for all the years, and it was giving the clear signal that in case of El Nino, there will be late monsoon onset, and in case of La Nina, there will be early monsoon onset. Now, the concern is that, is there any possibility of change in the origin of El Nino or La Nina? Because we have already seen that the temperature of ocean is now increasing continuously because of the extra amount of carbon dioxide in the oceanic water. And that extra amount of the carbon dioxide in the oceanic water is increasing the temperature of ocean. And in case of El Nino, what happens? The sea surface temperature becomes warmer than normal. And if El Nino kind of situation becomes a new normal for the globe, then you can imagine the situation for Indian subcontinent, that new normal of El Nino for the Central Pacific will be very harsh for India, because it will guarantee drought or scarce rainfall. And if the new normal will come in the form of La Nina, then again there will be excess amount of the rainfall, which will cause flood or cloudburst kind of events in the mountainous range. So this is the annual spatial analysis, and we got the connection that El Nino, La Nina have a very good connection with the onset of the monsoon in India. So here you can see through this figure that in India, we have very significant trend of monsoon onset for some different regions. And this result is based on the Mann-Kendall test. You can see here in panel B, sand slope is very significant for Haryana and Punjab and some northern parts of Rajasthan. So it is showing the early onset of the monsoon, which is 90% significant, right? And in some other locations of India also, we are having some significant result, which is significant by 90% as far as the monsoon onset is concerned. So with this discussion, we can say that when we try to study the monsoon or monsoon dynamics, there are some limitations, even with the technological upgradation, whatever instruments or supercomputers we have, there is limitation of computing for loop and bootstrapping at the pan-India level, because at pan-India level, whenever we do process our data, it gets processed for 32 lakh square kilometer area, and if the resolution of the data is very fine, then our personal computer will not be able to process that simulation or whatever loop we do want to run. So to study the monsoon, we need to have a very good computational power in the form of supercomputer, or the cloud computing is now again a very good option nowadays. So the second important limitation is stochastic atmospheric event intervention. I have already mentioned repeatedly that monsoon in itself is a very complex phenomena, and a lot of disturbance with the progression of the monsoon keep on taking place, like Madden-Julian oscillation, jet stream. All these are the disturbance in the progress of the monsoon, and sometimes whenever we say that yes, we have understood the mechanism of monsoon, something new happens in between, which again increases the complexity of the monsoon phenomena. So monsoon in itself is a very complex phenomena, and stochastic means some random atmospheric events keep on taking place in between. In case of India, we have very, very less density of the rain gauge stations in mountainous areas like Himalaya. And therefore, when we have very less density of the rain gauge stations in the Himalaya, it becomes very difficult for us to study the performance of the monsoon in Himalayan region. Because when we don't have the data, what we will study? We need data. And therefore, the only option we have is the satellite data. But we cannot replace rain gauge station based data with satellite data, because ground based accuracy is more higher. So again, the last very important limitation to study the monsoon dynamics is unavailability of the reanalyzed data for zonal wind, meridional wind, cloud cover, geopotential height. So there is unavailability of the reanalyzed data to study the monsoon in a very fine manner with high accuracy and precision. So now let's look into the changes which has taken place due to the climate change. We have discussed the geological history of the Earth, and we have connected it with the climate change, climate variability, and then we discussed the monsoon in India, monsoon trend, monsoon onset. We have discussed a lot of things. Now at the end, I would like to highlight the comparison between the past and the present. So when we compare the temperature, what was the temperature in the past? So here we can see in different time periods, the temperature was different, right? So approximately 20,000 years ago, temperature was 4 to 7 degrees Celsius lower than today. But at present, temperature is higher by 1.2 degrees Celsius as we compare it with the 19th century. So temperature is increasing rapidly in a very short period of time. So why is it happening? Why? Because atmospheric CO2 level has increased. In the past, the atmospheric CO2 concentration was only about 180 to 280 ppm, right? But at present, we have 420 ppm in 2023. Sea level has already increased, and the current rate of sea level rise is 3.3 millimeter per year. And the projection says that the rise by the end of 21st century will be in between 0.6 to 1.1 meter. And 1.1 meter rise will definitely sink the cities like Mumbai, Visakhapatnam, and various other coastal cities. Not only Indian cities, but I'm talking this phenomena will take place globally. So ice sheet and glacier melt is also taking place, and it has accelerated in the recent past, right? So here we can see through an example of the Greenland that between 2002 and 2021, Greenland has lost approximately 4,000 gigatons of ice, right? Mountain glaciers are melting continuously, and IPCC has already given its estimate for the end of 21st century, right? So as far as the Antarctica ice loss is concerned, so it was about 2,720 gigatons between 2002 and 2021. Ocean acidification also we can compare that what was the level at the time of pre-industrial time period. It was about 8.2. The pH level of the ocean was 8.2, but the projections shows that by the end of 21st century, the pH level will be in between 7.8 to 7.9, which will be about 100 to 150% more acidic than the pre-industrial level. And it will be very difficult for the different organisms in the oceans to survive in that acidic water. And you can imagine the situation, how difficult it will be for the coral reef, because coral reef changes its color if the pH level or the temperature of the sea surface changes. So it gives the signal by changing its color, and coral reef is one very important part of the oceanic ecosystem. So with the change in pH, there will be change in the oceanic currents. Circulation, there will be again a danger for the organisms surviving in the oceans, right? So we have already discussed that the intensity and the magnitude of the extreme events like the heat wave, cold wave, floods, wildfires will increase. I am here in Uttarakhand, and I would like to highlight one very important fact that out of all the wildfire events in India, about 75% forest fires or wildfires takes place in Uttarakhand. And yes, we can say that not only climate change is responsible, human factors are also responsible for it, but we need to control this. And we all know about the wildfires in Australia, California, and Mediterranean. Wildfire is very huge. In wildfire, we call it because it goes out of control. So heat wave, cold wave, flood, all these kind of extreme events will increase. Their frequency and intensity will increase. So in conclusion, I would like to say that unprecedented change has taken place since the origin of the earth. There was the natural rate of climate change, which used to take place in million or billion of years. But now, with the increased concentration of the greenhouse gases due to the industrialization, whatever have changed in the million of years or billion of years is now changing in few decades. And this is because of the human intervention and industrial revolution. So we need to have global cooperation to control this. Why? Because each and everything is connected from each other. If we will increase the level of carbon dioxide, it will directly go into the oceans, and oceans will increase their temperature. It will lead to the ice melt and various other events which are the result of climate change will take place. So there is interconnected nature of different episodes. So we need to control all this using global cooperation, and a lot of have changed. So we also need to mark the deadline, and we can call it the time sensitive action. Why? Because we do not need take it for granted. Why? Because we have already seen the rise in temperature. 1.5 degrees Celsius has already increased in the past, and if the window of limiting global warming to 1.5 degrees Celsius above pre-industrial level comes closer, then we need to intensify our action to control the climate change and to reduce the greenhouse gas emissions. So this is for today, and I hope you must have enjoyed the whole presentation, because we started from the geological history and we discussed till present, and we have also discussed something about the future projection. So from the geological history to the future projection by the end of 21st century, we have discussed everything, and in the last 1.5 hour or 2 hour, there was an overview of the whole climate urgency or climate crisis. So thank you.
Thank you, sir. Sir, if you want, we can take some questions from the students.
Yes,
Is
definitely.
there anyone?
Good evening, sir.
Good evening. Good evening.
First of all, from your PPT and presentation, it is evident that you have worked rigorously on this on this vast topic. Thank you very much for in-depth knowledge, providing us in-depth knowledge and the scenario. I just want to know that, sir, what are the different methods that you have used to predict those projects and the impact, whether it is for temperature or the impact, different impact.
Okay, so Jayanta, so the question is from Jayanta. The question is
Yes, sir. Yes, sir.
yes. So the question is very interesting. How we have used different methods to have the future projection for different regions in India. So actually, as I have mentioned, that there is an international body called IPCC, and it releases its assessment reports after time interval. So the recently released report is assessment report 6, and with the release of all these assessment reports, there is also a data set which is released with the assessment report. So the recently released data set is CMIP 6. CMIP 6 data set is based on the simulation of climate. So there are thousands of scientists which are part of the IPCC, right? And there are different institutions based in different countries which work continuously 24/7 to see how the climate will change in different regions or in their own country. So what do they do? Those institutions based in different countries, they do create a different scenario for different regions. Maybe it is for their own country or some larger part of the globe. So they do create a scenario for a particular region, and for that region they simulate the data set. Simulate the data set means on the basis of emission of greenhouse gases, what will happen by the end of 21st century, what will happen in the mid of 21st century. So the simulation needs high computation power. So the most eminent institutions, like one very important I would like to name is from the Germany, that is the Max Planck Institute. So Max Planck Institute also contributes in the future projection dataset. All the different institutions from different countries contributes their own dataset, and it is submitted to the IPCC. And on the basis of that dataset, the whole assessment report is created, and that whole assessment report produces the future projection scenario for the whole globe. So you can also use that data set which is ready to use, and the particular format of that data set is NextCDF. You can convert that format in your own convenient format. So that data set is available on different platforms, which is in ready to use mode. You need to have the knowledge of R programming, Python, or some different programming languages to handle that data set. So you can directly use it, and you can also use different statistical methods to get result as per your own need. I mean, if you are using the data set for a time period of 2080 to 2100, then on that period of data set, you can use your own statistical techniques to get the result which is required as per your research objective. So the data set is in ready to use mode. You can directly download it. You can use different statistical techniques. You can use different programming languages to use and to change that data set as per your own need. So I think this is the answer to your question.
Yes, sir. Yes, sir. Thank you, sir. Whenever something is required, I will ask my friend there to contact you for any kind of advice regarding these topics. Thank you, sir.
Sure, sure.
अभी सही नहीं हुआ
Sir, this is Rajkumar. Sir, I want to know which DCM data sets are more suitable for Indian subcontinent region. How to find it?
So this question comes to the mind of different researchers, and especially to the mind of PhD scholars, because we have huge data set available on different platforms in India and across the globe. We can access it from anywhere. So for India, there is MIRO CSM dataset, which is very much suitable. But yes, with the release of CMIP6 dataset, there are some new studies, recent studies, which you should also go through and identify which new dataset is more suitable for India. Because when we talk about the CMIP5 dataset, there were different data which were part of the dataset. Now in CMIP6, there are different models. So maybe a new model which was not part of the CMIP5 and is now the part of CMIP6 is more suitable comparatively for India. So you can also go through the recently published study. But yes, MIRO CSM dataset is very suitable for Indian subcontinent as far as the CMIP5 is concerned.
Okay, sir. Thank you.
और नहीं बहुत हो गया बंद कर बहुत हो गया बंद कर
Anyone? Anyone? Okay, I guess no more question. So we are now end of our lecture session. So good afternoon, everyone, once again. So today, I'm sure Dr. Saini have discussed so many things about the climate change from the how the climate change have started from the past to the present, how because of climate change the scenario like change in the Indian monsoon, changes in the sea level rise, changes in the crop harvestation, and change in uh, disease, your vector-borne disease. He have mentioned them more clearly, more elaborately, and he have discussed the how Indian monsoon, how what the very basics of Indian monsoon, which is very much useful for the postgraduate student, and how the factors are very much important for playing a important role in Indian monsoon. That is the La Nina and El Nino factor, and what is the impact of the monsoon, the onset, the delay onset of monsoon or earlier onset of monsoon. Because of that, there is cloud bursters there, intensive rainfall are there. He have given a very brief example of such event which occurred throughout India since decades. I'm sure that help our student, our listeners, help very much. So thank you, sir. Thank you for giving such informative lecture to our student, scholar, and also there are other academicians from other universities and colleges are there. So thank you very much, sir, for your time and for your informative lecture. I would like to thank to our all the participants, the students, the scholar from the department and outside the department, from this university, FMU University, also from other universities of Odisha. Would like to thanks all the colleagues of our department to patientful listening. Thank you, everyone. Thank you all.
Thank you,
Thank you,
madam.
sir. So now we can left, sir. कोई बात
अरे धीरे 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 मानस